Hello guys, in this video we are going to discuss about the solution of second and higher order differential equation. Okay, so the standard form is given over here. This is basically a homogeneous differential equation, and this is a second order differential equation. You can see over here the degree is 2, and here you can observe I will consider d is equal to d by dx, such that d square, this will become what, d is d by dx, then this term will become d square into y, plus p is a constant and as well as q is also a constant, and this will become dy and q into y as it is equal to 0. This is the equation. Then I'll take y common, so that it will become d square plus pd plus q whole into y is equal to 0. Now I have to write the auxiliary equation so that I can find the roots. Now converting into auxiliary equation is simple. What you have to do, you have to consider d is equal to m. So this will become m square plus pm plus q, where p and q are constants. Now moving further, so after doing this equation, after finding out auxiliary equation, this can be for the cube as well as cube also. Whenever you get third degree, you will get it as 3 roots. Here it is second degree, so you will get it as 2 roots. So considering 2 roots, there are certain cases in which you have to see. The first case we can see over here, real and distinct. Whenever you get m equal to, you have to solve this equation. Okay, you can solve it in by factorization, or you can use a calculator as well. Now m is equal to alpha comma beta, that means 2 real and distinct. Real and distinct means they are different as well as they are real numbers. In such case, your solution will be y is equal to c1 e power alpha x plus c2 e power beta x. Okay, for the real roots, real and equal roots, m is equal to alpha comma alpha, where this will be what, equal roots. In such case, I can write it as y is equal to c1 plus c2x whole into e power alpha x, where alpha will be the root which are repeated. Okay, now moving further, the third case, roots are complex number. Whenever you get complex numbers, as that alpha plus I beta, where alpha is the real part, beta is the we can see the both are but complex number, imaginary part. Okay, both are complex numbers, alpha and beta. Alpha plus I beta are together is a complex number, and alpha and beta are what, real numbers. Okay, this you have to see. Now y is equal to e power alpha x into whole into c1 cos beta x plus c2 sin beta x. So this is a solution for the given roots whenever you get complex number. So in case if you get only the imaginary number, okay, imaginary part, this is what, both containing both part. Whenever you get the imaginary part only, then you have to consider what, y is equal to c1 cos beta x plus c2 sin beta x. Here alpha is not playing any role in that, so we have to remove this part. Okay, that's it. This is the 4 cases we can consider whenever you have to find the solution. This is for the homogeneous differential equation, where in case you will get the differential equation in this form. Okay, so let us see a few questions based on this. The first question, here it is y double dash plus 5y dash plus 6y. Now don't get confused between the standard form and this. This is y double dash means second order, so basically it is nothing but d square y by dx square. Okay, and y dash means dy by dx, that's it. And here you have to consider d by dx as what, d. So the equation becomes y double dash d square y plus 5 dy plus 6y is equal to 0. So from this I can take what, y common, so d square plus 5d plus 6 into y is equal to 0. This is the first step you need to do. Next, you have to convert this equation into auxiliary equation. Okay, auxiliary equation simple. You have to consider only d part. D part means d you have to convert it to m and remove this y, that's it. Okay, So auxiliary equation becomes m square plus 5m plus 6 equal to 0. Now we need to solve this equation. So I'll just feed it in the calculator so it's easy. So basically you have to go for mode equation, then the third option, since it is power is 2, so I'll go for the third option. Here you can just feed the coefficients of each. That m square means coefficient is 1 and 5m coefficient is 5, then the constant c 6. You can see over here minus 2 and one more value will get minus 3. So roots are, or you can directly go by splitting the middle term, factorization of the given equation. Now so I got the roots as m equal to minus 2 and minus 3. You can observe here this lies in which case where the roots are real and distinct, where roots are different as well as they are real numbers. So in such case the solution will be y is equal to c1 e power alpha x, alpha you can consider this, plus c2 e power beta x. What is beta over here? Minus 3x. So this will be the final solution. So I'll just explain you once again. Here little bit confusion will be there whenever you see this type of problem wherein y power y double dash basically means d square y by dx square, and d by dx you have to consider d by dx I am considering it as what? Equal to d. So this becomes, so y double dash you can directly write it as d square into y dash means dy, that's it. Then y remains as it is, then you have to take common y, then auxiliary equation you have to ignore this y and just replace d with m, then find the roots and you have to check whether in which case these roots lie. So this is the case, this is the problem we have solved.